Hey guys, this is Mr. Gudino and this is section 1.1 rectangular coordinates. Our learning goal for this section is to use a Cartesian plane to represent relationships between two variables. We'll know we've accomplished this when we can plot points in the Cartesian plane, when we can use the distance formula to find the distance between 2 points, and when we can use the midpoint formula to find the midpoint of a line segment. So let's go ahead and jump right in. On the right side of the screen, I have a picture of a coordinate plane, otherwise known as a Cartesian plane. But before we get too deep into things, let's talk about a few highlights about the Cartesian plane. So first and foremost, as you may already know, there are two axes in the Cartesian plane. We have our x-axis, which runs left to right and horizontal, or we have our vertical axis, which is our y-axis that runs up and down. Now these two axes, they split our grid into 4 distinct pieces, which we're going to call quadrants. And each one of these quadrants has a special name, and in reality it's a pretty conventional name. So this top right quadrant is just simply called quadrant 1, and oftentimes you'll see them denoted with Roman numerals. And as we go counterclockwise, our next quadrant on the top left, that would be quadrant number 2. And our next one on the bottom left would be quadrant number 3. And finally, quadrant number 4 is the bottom right. So that's one key idea in this section. Just make sure you're able to recall the quadrants and where each one of them goes. And we're going to touch on these a little bit later on as well. However, another important idea is if we look at where our two axes intersect right in the center here, that is what we call the origin. And as far as its location on this grid, it would be at 0, 0. So also remember that a grid, or the Cartesian plane, is kind of like a two-dimensional map in which we can move using these ordered pairs. So if you recall from your previous classes, these ordered pairs, we write them in terms of x and y, where x, which is the first number in the parentheses, tells us how much we're moving left or right, or how much we're traveling along the x-axis on our grid. And likewise, our y value in this ordered pair is going to tell us how much we're moving up or down. For your x-axis, you're going to travel to the right side specifically when your number in the ordered pair is positive, and you're traveling to the left side when you have a negative number. And again, for the y, when y is positive, you're going up, and when you have a negative y, you're going down. Do notice, however, that the x always comes first in that ordered pair. You're always moving side to side first before you move up or down. So let's go ahead and plot some points out. We're going to use what we talked about in the last slide to kind of figure out where these coordinate points go on our grid. So if we look at this first example, remember we always have our x value in the ordered pair first, then our y. And for our x value, we have a -1. That means we're going to move to the left 1 unit. And for y, we have a +4, so we're going to move up 4 units. So if you go over to our grid, so we can plot this out, remember we always start in the center here. Now for this example, I'm going to trace each one of my steps just so you see how we get to our final destination here. So if I'm going to go left 1, I would be here, and then I'm going to go up 4 units. And so my final point, my final answer for this problem would just be the point located at -1, 4. And why don't we call this point point A, just so we can keep track of these. So if we look at the next example, I have 4, -3. Here our x value is +4, so we're going to move to the right 4 units. And we have a -3 for our y value, so we're going to move down 3 units. And if we go over to our grid and plot that, again, we always start at the origin here. We're going to move 4 units to the right, and then I'm going to shift 3 units down, and my point would be located at 4, -3. And I'll go ahead and name this point point B. Now for the next one, notice we have a x value of 5, so we're going to be moving 5 units to the right, but we have a y value of 0, so we're actually not going to move up or down at all. So if we start at the origin, move over 5 units, point C would be located here. And if we go over to the last one, we will call this one point D. Notice x value is 0, that means we're not moving side to side at all, and y is -1, so we're going to move 1 unit down. And so our point would be here on our grid. Now that we have an idea of how to plot points, we're going to focus on a few of the relationships between points. So first, we're going to focus on the distance formula. Now, when we're trying to find the distance between 2 points, we're just trying to find the length of the segment that is created when you connect those 2 points, as I have just done in blue. And to find this distance, we're going to use a special form of the Pythagorean theorem, which you might recall from your previous classes. In class, I'll go into this in a little bit more detail, but essentially, instead of using a, b, and c from the Pythagorean theorem, we're going to use the coordinates of the points that are on our graph to figure out what the distance formula is. And here it is. So once again, we will go in a little bit more in depth in class how we obtain this formula from the Pythagorean theorem. But for now, and after we cover a few examples, the main thing I want you to get out is how to use and apply this distance formula. So let's go ahead and actually put this formula to use with some points. The 2 points I'm going to be using are -5, 2, and 3, -4. And our job is to find the distance between these 2 points that, as you can see, I already graphed using our distance formula. And before we get started, one suggestion I have whenever you're using the distance formula is to label your ordered pairs. So this is going to be x1, comma, y1, and our other point is going to be x2, comma, y2. That way you can see exactly where you have to plug in each value to your equation. So now all we have to do is go in and replace your x's and your y's into the distance formula to figure out what the distance is. So here, in the first set of parentheses, we're going to have x1, which we said was -5, minus x2, which is 3, quantity squared. And then plus y1, which is 2, minus y2, which is -4, quantity squared. And if we simplify this a little bit, -5 minus 3 is -8, quantity squared, plus 2 minus -4, be careful with your signs here, we're going to have a +6 squared. And if we simplify a little bit further, -8 squared is 64, plus 6 squared is 36. So 64 plus 36 gives us 100, and the square root of 100 is 10. So the distance, now that we've completely simplified, the distance between the 2 points we had initially is exactly 10 units. So let's do one more example of the distance formula. Now, anytime we're doing practice problems like this, I recommend that at this point you stop the video and you try out this one now that you've seen one example, and then check your answer with my work that's coming up. And like I said last time, I recommend that you label your coordinates before you get started. So this will be x1, y1, and we'll have x2, y2. And once we're in, we're just going to plug into our distance formula. Make sure you're plugging in correctly and carrying the signs with you. So x1 is -6 minus x2, which is 8, all of that quantity squared, plus y1, which is 1, minus y2, which is 4, quantity squared. If we simplify this a little bit, we get -6 minus 8 is -14 squared, plus 1 minus 4 is -3 squared. And if I simplify a little bit further, -14 squared. Again, if you're using a calculator, make sure you're including parentheses. that include your negative sign, so you don't have any errors there. But that should be a positive 196 plus negative 3 squared is 9. And so 196 plus 9 is 205, which at this point, unlike the last example, this isn't a very nice number to square root, so feel free to use your calculator, and you should get something around 14.32 if you round to the second decimal. So if we look at that on the graph, negative 6, 1 would be here. 8, 4 would be about here. And the distance, this segment in red, would measure about 14.32 units. So the next thing we want to do is, given 2 points, we'll call them again x1, y1, and x2, y2. As the name suggests, we're going to try to find the point that is exactly in the middle between those two. So if you think about your math terminology, whenever you're talking about the middle of certain values, really you're just talking about the average. And that's exactly what this formula here is doing. It's taking your two x values, adding them together, and dividing by 2 to find the average between them. And then you're going to take the two y values, divide them by 2, find the average change in y, and that'll create a new ordered pair, which is going to be the midpoint. And visually on a graph, what we're doing when we use the midpoint formula is, for any 2 points that we choose, we're trying to figure out what is this point exactly in the center and what is the coordinates of that point. So let's try one of these out. Now, if it helps you, definitely label the points just like we did with our distance formula before you get started here. But if you feel comfortable enough, you don't have to do that every time. So our midpoint is going to be x1 plus x2. So negative 5 plus 3 divided by 2. And our y coordinate is going to be determined by y1 plus y2. So 2 plus negative 4 divided by 2. We're going to go ahead and simplify this a little bit. Negative 5 plus 3 is negative 2 divided by 2. And then 2 plus negative 4 is negative 2 divided by 2. And for each one of these, negative 2 divided by 2 is just negative 1. So the midpoint between negative 5, 2, and 3, negative 4 is the point at negative 1, negative 1. And if we look at that on the graph, again, we're going back 5 units and up 2 for negative 5, 2. Then we're going to go right 3 and down 4 for 3, negative 4. And our midpoint that we just found is going to be at negative 1, negative 1, which it just looks correct. It definitely seems like it is exactly in the middle between our first 2 points. So let's do one more. And once again, I recommend you try this before you watch this section of the video. But here we're going to have x1 plus x2, so negative 6 plus 8 divided by 2. And y1 plus y2 is 1 plus 4 divided by 2. And we're going to go ahead and simplify this out. Negative 6 plus 8 is going to be 2 divided by 2. 1 plus 4 is 5, so we have 5 over 2. And 2 over 2 simplifies, so we get just 1. And 5 over 2, that's not a fraction we can simplify unless you want to write it as a fraction. However, I recommend anytime you have fractions, just leave them that way. And finally, over on our graph, negative 6, 1 is about here. 8, comma 4 is over here. And our midpoint that we just found is over 1 and up 5 over 2. Which is about 2.5, so that would be somewhere around here. And finally, your high-level question for this section is, using the Pythagorean theorem, whichever form of the two you are more comfortable with, I would like you to show your work and try to derive the distance formula, which we've seen quite a bit today.